All right, so now let's take a look at implicit differentiation when y is a function of t and x is a function of t. So when y is a function of x, that's the only time that we use dy over dx or y prime. So when we're taking the derivative of y with respect to t, we need to write dy over dt. dx with respect to t, we've got to write dx over dt. So here's an example. So here's your function, but here they're telling you that y and x are a function of t. So you could think of this like that. Now when I take the derivative with respect to t, I get dy over dt. This 2 comes down, so I get 8x to the 1 power times dx over dt, and the derivative of x with respect to t is dx over dt. Again, you do not use x prime or y prime when you're talking about dx over dt or dy over dt. It's an illegal move, so it doesn't work. So now I take this and I use x equals 3 in for the x, and I use dx dt equals 10, and I get my answer. All right, let's do another one. So here is the function. Here I can see x and y are both functions of time. So taking the derivative with respect to t, I get dy over dt. Do the chain rule on this. So I get 1/2 x to the negative 1/2 times dx dt. Then I plug in x, dy over dt is 2. Plug in x is 25. You know that that's 1 over the square root of 25. And then dx over dt, solving here, and I get 20. Looking at the next one. So now I have x squared and y squared. All right, so let's look at this. So I'd have doing chain rule on both x and y. So you get 2x to the 1 power times dx over dt. 2y to the 1 power times dy over dt, and then the derivative of 25 is 0. So now, let's see, I plug in x equals 3, I plug in dx dt is 8. Oh no, I have y here. They didn't give me any information on y. So what I need to do is I need to find y, and how I'm going to do that is I'm going to use x equals 3 in my original equation, and I get y squared is equal to 4. You really do get a plus or minus, but I'm going to use y equal positive 4. I put that in, and I'll get dy over dt is negative 6. All right, here we go. So x equal y cubed minus y. Find dx over dt when y is 2 and dy over dt is 5. So take the derivative, 3y squared dy over dt minus dy over dt, and then plug in the information for 2 for y. Dy over dt is 5 and 5, and there we are. All right, let's get some different letters going on because you're going to encounter problems with lots of different letters. So here's the volume. And this is a dv over dt is 100. R is 4, r meaning radius. Find dr over dt. Taking the derivative with respect to t, dv over dt. Carry along the 4 pi. Take the derivative, 2r times dr over dt. Then plug in the information of a dv over dt is 100. Plugging in r is 4. I get 8 times 4 is 32 pi, and there it is, 100 divided by, 32 pi. It should be 32 pi. All right, let's go to the next one. So here's dr over dt. R is 3. Find dv over dt this time. So again, go and take the derivative, carry the 4/3 pi along, take the derivative, 3r squared dr over dt. Substitute dr over dt is 5 in there. Substitute r equals 3 in there, and I get 180 pi. Okay, this one here is taking the derivative, derivative of a with respect to t is dA over dt. Carry the 4. Derivative of sine is cosine of theta. Now take the derivative of theta. That's d theta over dt. So d theta over dt, they're telling me is 2. The angle is pi over 3, and I'm finding this, and you know cosine of pi over 3 is 1/2, so I get an answer of 4. All right, let's stop there and we'll continue on in the next video.